Hello, this is Dr. Christy Patton-Lukes, your instructor for Chemical Engineering 3111 Numerical Computing. And we're working on solving systems of linear equations in Lab 6. In this lesson, we've looked at several techniques. Cramer's rule is one that is okay to do. It's a little bit of a pain in the neck on the computer, but it's possible. The matrix inverse technique is probably the most useful for linear equations. It is definitely the easiest to program in the computer, and it works very well. We talked briefly about the Gauss-Jordan method, and then more about the Gauss-Seidel method, which is successive substitution. And although this one is more of a pain in the neck to use, you have to use it very carefully. You need to order the equations so that you use them in the order of the variable that has the highest coefficient in order to get guaranteed success. But it's a good method to study because it's going to work when we get to nonlinear systems. And so what we want to do this week is practice these techniques. So in today's activity, we're going to be making candies. Now, I encourage you to do something, along with me, but you don't need to. So I made mine from what ingredients I could find on hand that would be simple and still taste good. So I used Cheerios, dried cranberries, and some white candy coating. I had 17 grams of dried cranberries, 12 grams of Cheerios, and 52 grams of candy coating. Then I took the candy coating, I melted it in the microwave for 1 minute, and then it wasn't quite melted, so another 20 seconds. I stirred in all of the cereal and all of the cranberries, and then dropped the mixture onto waxed paper in 4 different clumps, and then allowed the candy to cool. At the end, I did have leftover candy coating in my cup, so I had 5 grams of candy coating that was not used. So subtract that out from the mass I had earlier. Okay, so there's our candies that we made. And what I want you to do is do some calculations. And I want you to actually use mass and energy balances and write actual equations to solve for how many calories in these candies, how many grams of total fat, how many grams of sugar, and how many milligrams of sodium in the total mixture, and then again how much is in the average candy. Now in this case the average candy was just 1/4 of it, so divide your total by 4 and you'll have the average. In order to do this, you will need information from the nutrition fact label. So, okay, this is the dried cranberries, and 40 grams has 130 calories, 0 grams of fat, 29 grams of sugar, no sodium. Cheerios, 28 grams, has 100 calories, 2 grams of total fat, 140 milligrams of sodium, and 1 gram of sugar. And the candy coating, 47 grams, has 250 calories, 13 grams of total fat, no sodium, and 33 grams of sugar. Now, you're going to do that and you're going to get an average for one of the candies that we made. And then what I want you to do is, the reason I asked you to do that by actually writing out equations is now then we're going to flip those equations around. And so I want you to write those equations where now the variables are the mass of dried cranberries, the mass of Cheerios, and the mass of candy coatings. And our goal is to create a recipe that will be for a candy, an average candy that's 85 calories, 3 grams of total fat, and 8 grams of sugar. So I want you to then solve that system of equations, and I recommend that you try all the different techniques we looked at, and then determine the mass required for each one for this goal nutrition fact label. Also then based on that, tell me what's the mass of sodium in the product, And then when you upload your work, I want you to, in the comment box, tell me what's the calories, what's the fat, what's the sugar and sodium of our creation, and then what's the recipe for this 85-calorie candy. So this concludes our exercise for this week. You can choose to make your own candy or not. You can do it based on my recipe, okay? But have a little fun with this. Thank you very much for your time.